Okay guys, let's do some rational word problems. Now the good news about the rational word problems is that they're actually easier setup-wise than the general equations for rationals. So let's just generally talk about work rate. If it takes you, say, 8 hours to do something, then your rate of completion is 1/8 of the job per hour. And there's a general idea here as follows. If you combine two rates, like two people are working on things together, it's their rate per hour added together is their combined rate per hour, so long as they're not distracting each other. So if Jane can paint a room in 3 hours and Jill takes 7 hours to do the same job, how long would it take to work together? So Jane's rate is 1/3 per hour. Jill's rate is 1/7. Since they're working together, it's plus. That equals 1 over the combined rate, which is what it wants to know, so we call it x. Now, what is our common denominator here? It's 3 times 7 times x, so we multiply by 21x. (21x) divided by 3 is 7x. 21x divided by 7 is 3x. 21x divided by x is 21. We now have like terms, so we have 10x equals 21. Divide by 10. X equals 21/10, or 2 1/10. If we're talking time, 1/10 of an hour, 1/10 of 60 minutes, it's 2 hours, 6 minutes. Any of these is fine. Just make sure your homework may want it in a specific way, so keep that in mind. One printer does a job twice as fast as the other. Together they finish the job in 2 hours. Find the individual time completion rates of each printer. So if the first printer, the faster one, takes X hours to complete the job, then the slower one takes twice as long, so 2x. Together, they finish in 2 hours, so 1 over x plus 1 over 2x equals 1/2, because it takes 2 hours to complete. Here, my common multiple is just 2x. That's all I have to multiply by. So we get 2x times 1 over x plus 1 over 2x equals 1/2, distributed to all of these. 2x divided by x is 2. 2x divided by 2x is 1. 2x divided by 2 is x. So 2 plus 1 equals x. That means 3 equals x. That means the fast printer takes 3 hours. To do the job by itself. The slow printer takes twice as long, so that must be 6 hours. Okay, and a slightly different take on the same kind of problem. A bathtub can be filled in 8 minutes. The drain can empty it in 13 minutes. If you turn the water on, but you accidentally leave the drain open, how long will it take to fill? So in these previous ones, the two rates were working together. Here, the bathtub is working to fill up, but the drain is actually working against the bathtub filling up. So instead of plus, it's now 1/8 minus 1/13 equals 1 over x, because the drain is actually working against the faucet. My least common multiple, I need to multiply 8 times 13 times x, which is 104x. And distribute. 104 divided by 8 is 13x. 104 divided by 13 minus 8x, and 104x divided by x is 104. So the setup is exactly the same, you just have a minus in between. So 5x was 104 divided by 5. So x is 104 over 5, or 20 4/5, which we would call 20 minutes. In this case, 4/5 of a minute is 48 seconds. It's a lot of used water, but maybe still less than you use in the shower. Now, one thing you notice about all of these problems as kind of like a shortcut, what was left up here, for example, with the 7x, it was the denominators from the other two parts of the fraction. And that's true kind of all the way over for all of these where there's just 1x. So that's a little shortcut if you want to use it. Okay, so now we're done with rationals. Let's move on to radical equations. For radical equations, your goal is to isolate the radical, eliminate the radical by raising to a power, possibly squaring, solve the equation, and checking for solutions. The easy problems are when you have the same radical on each side, number 8. The medium difficulty is roughly number 6. Number 7, because there's two different radicals, requires squaring twice, and we'll see when we get there. Okay, so goal 1, isolate the radical. So I'm going to add the radical to the other side. So we get x equals the square root of 15 minus 2x. And here, to get rid of a radical, we square, because this is a square root. Now, we're going to have to check our answers when we're done, because we are introducing a square. And so one thing you have to remember is that 4 is not equal to negative 4, but when I square them, they're both 16, and so it will appear equal. As a result, I must check my answers when I'm done. So we get x squared equals 15 minus 2x. This is quadratic, so I'm going to move everything to one side by adding 2x and subtracting 15. This will allow me to factor x plus 5, x minus 3. Now remember, for factoring, you're looking for two numbers that multiply to negative 15 that add to 2. So either x is negative 5 or x is 3. And I set them equal to 0. Okay, so I need to take these and plug them back in. So to the original. So let's take negative 5. We have negative 5 minus the square root of 15 minus 2 times negative 5 is supposed to equal 0. Now, negative 2 times negative 5 is plus 10. So this is negative 5 minus the square root of 15 plus 10. 15 plus 10 is 25. So that's negative 5 minus the square root of 25. The square root of 25 is 5, so we get negative 5 minus negative 5 minus 5 equals 0. Now, what is negative 5 minus 5? It's actually negative 10. That's bad. Negative 10 is not equal to 0, so this is a case where when I moved this over, I had a negative 5 equals 5, and when I squared them, they appeared to be equal, but they weren't actually. So this answer is bad. Let's check 3. 3 minus the square root of 15 minus 2 times 3 is supposed to equal 0. 2 times 3 is 6. 15 minus 6 is 9. So it's 3 minus the square root of 9 equals 0. Square root of 9 is 3. Is 3 minus 3 equals 0? Yes. What does that mean? It means x equals negative 5 was a bad solution, but x equals 3 is a good solution. So my only answer is x equals 3, and we will do more in the next video.